Okay, question 3, vertical projectile motion. Sisaphendula na question yethu ka June exam 2023 abalibhale Gauteng. Check out the description box for links for amanye questions ongaphendulile for this question paper. Thanks for tuning in. There's also a link to another channel for AMA lessons. Check it out as well. Now we are subscriber to that one. I'd appreciate that as well. So question 3, basipha a softball, bathatha the softball by ponza vertically downwards towards the ground, whereafter it bounces back up as illustrated in the sketch below. So let the softball, it could be a tennis ball, figure lagu ground ya bouncer, then it goes all the way up to height number B, right? So a softball, imagine a tennis ball. That's a good example of a softball. Lifika lapha ku ground lenzani liyoshayisana ne ground, but le bhola leli naloshayisana liyofika lipotoke kancane, right? Liyopotoka ngoba linjani, lisoft ngisho. So loshayisana ne ground poto, nalifika lipotoke la lizoba in contact with the ground for a certain amount of time. Then after liqeda ukupotoka ngisho le bhola lifike apply a force towards the ground, then with that load thini, the ground will also apply a reactive force on the softball in the opposite direction. So naliqeda ukupotoka, uma kahle le bhola nalipotoka lisuke apply force to the ground. Naliqedile ukupotoka, during that contact time lisuke transfer energy to the ground, or lisuke apply force to the ground. After this contact time, ground yenzani, ibuyisela favor back according to third law ka Newton. If for object A you apply a force on object B, B will also apply an equal force on object A but in the opposite direction. Then after the contact time, le bhola liyapotoluluka kanje. Liyapotoluluka, angazi ukuthi likhona igama lisho njani, nangazi ukupotoka. The opposite of ukupotoka, liyaluleka le bhola. Bese lenzani, liyaluleka liba round again, alisabi ngathi ibhontshisi nyana. So then lenzani, liyasuka liyaphezulu lifike libambe ubani height number B, which is the maximum height after the first bounce. Into bengifuna ukuyichaza yilena, right? Bese babuya ke baqhubeka, but when the ball reaches point A, it has a speed of, so this is our initial velocity la, right? Lagu A, the height of A is 5 meters above the ground. The ball hits the ground and bounces up to a maximum height at position B. Assume that the air resistance is negligible, so we ignore any air resistance. So lagu 3.1 babuye bathi explain the term projectile motion. So yonke lento bebayichaza la, the throwing of the ball, bouncing off the ground to come to this point, this maximum point ka B. This whole thing because I projectile motion, but she explain la. Projectile motion, it's when an object moves under the influence of gravity kuphela. Hence we were ignoring or assuming that the air resistance is negligible, right? Once air resistance is considered, aksabi projectile motion, only gravitational force must be at play. Then leyo object oyiphonsayo or oyidropayo can be considered a projectile motion. 3.2, calculate the speed of the ball as it hits the ground. Askiphi data kuqala la. 3.2 data, okay, bafunani speed, right? That's the final speed. VF unknown, V initial is equal to 8.4 meters per second. I'm assuming that the downward motion is in the positive direction. When we cater the negative direction, it's still fine. Okay, so not delta y which is also positive 5,0 meters. Yes, and then siba no G, which is 9,8 meters per second squared. This is plus ngoba gravitational force is always acting downwards. Now, so now data now I have to choose a formula again. So from the formula sheet is na 4 yama formulas of motion. Ngifuna v final, ngine initial, I have initial, I have acceleration, I don't have time, so the formula ngeke isebenze le. Ngifuna final, initial nginayo, acceleration, wait, why it's 2a delta a, it should be y la, or x, it should be y or x la. So therefore sizosebenzisa this formula to calculate our final velocity. Initial nginayo, gravitational acceleration nginayo, so therefore lana the final velocity squared is equal to v initial squared plus 2a delta y. So all right, I see now, I see kumele ngibuyele la ngibhale endaweni wrong. All right 2, so v final it's v squared v initial squared plus 2a delta y. nazo so sebenzisa this formula again. So v final squared is equal to v initial, it's 8,4 squared plus 2, 9,8 times 5 lapha, times 5, density 8,5 squared plus 2 times 9,8 times 5. This is equal to 168,560 v final squared, squaring both sides, then it's plus or a minus lapha. So v final is equal to a plus, let's take the square root of this answer, sithola u12,98 meters per second. So nayi answer yethu ke, so this is the final velocity. So le bhola nalidrop leli, boom le bhola nalidrop li pick up speed ngoba liya accelerator downward due to gravity. So obviously nalifika nalushayisa ground, obviously the initial speed will be less than the final speed, so that's why siba on 12,98 meters per second. Oh yeah, okay. Now 3.3, but he showed by calculation that the time for the ball to reach the ground is, again data is afana la. I'm still choosing down as positive, but this time is a calculator in it's for no calculator iskati. So I have let's see this time I'm for calculate iskati. Final velocity this timing now. How about this is 7 say this formula? I have initial, I have final, I also have delta y, which is this height, and for now delta t. You can also use this one, but I'm avoiding using a quadratic formula la ngoba so calculate isikhathi uyabona, so since quadratic formula la, so asiyekele that one, sizela. Let's do this. Sizela 3.3. Okay, erase lapha. Now delta y is equal to v initial v final over 2 times delta t. Delta y choosing down as positive 5, initial 8,4 plus v final 12,98 over 2 delta t. Okay, 8,4 times not times plus, since ufuna calculate delta t, you divide by this whole thing. All right, I think I create any confusion la tingenze so 8,4 plus 12,98 divided by 2, this is equal to 10,690 delta t 5, divide both sides by 10, 690 cancel, then delta t over equal to 690 ola 2 decimal places, we have got 0,47 seconds. Now answer it again. You can also use this formula right as an exercise for when zamali formula to calculate delta t, but use a quadratic formula. Use a quadratic formula. In the projectile motion with the, you have a lot of options for finding a solution. There's no like one way of calculating a thing. There's always other ways perform our calculations. Same goes with the work energy and power. Ngoba kunama energy principles amaningi. So ama questions anjalo yangichaza ngoba there's more than one way to kill a cat. Okay. 3.4. The ball bounces vertically upwards at a speed of boom. Le ball alifikelize la, li bounce off the ground, boom. Lizokwazi ukufika la kubani ku B. So all along we were doing our calculations for the downward motion. Now we are focusing on the upward motion. The ball bounces vertically upwards. Now we are focusing on this part of our journey, of the ball's journey. The ball bounces vertically upwards with a speed of, so now there's a speed of 4,2 meters per second after the bounce. As it leaves the ground, the time the ball is in contact with the ground, 0,20. Uyayibona ke manje ile nto bengikhuluma ngayo lokupotoka lo, nayipotoka iyosticka to the ground for this period ka 0,20. La ku 3.4.1 bathi, what is the magnitude and direction of the acceleration of the ball at B? What is the magnitude and direction of the acceleration of the ball at B? Okay, le ball analifika la ku B, I understand ukuthi le ball analifika la ku B liyoba stationary ngoba it's the maximum height. But for the fact ukuthi this is a projectile motion, choosing downward as positive, the acceleration yethu about 9,8 meters per second squared. Right, the acceleration is always acting downwards, whether stationary, usekhayikini uhlele toilet, or ulele, or awukho khayikini usesikolweni, i-gravity ihleli i-acta downward and izokuphula by this acceleration. Uyabona, you slip you fall. Hayi ukuthi uyalala uyawa, no, I don't mean that. Nangabe you slip you fall, ngikhuluma ngalo slip lo, wangaphunyuka uyawa. Wangaphunyuka uyawa, not this slip, ne? All right. Okay again. So to answer the question that 3.4.1, the answer is 9.8. Calculate the maximum height of that the ball reaches after the first bounce of the floor. Alright, I think erase it so that you can answer this question. Alright, now let's keep it data na. Izinto zijikile manje. Ungakhohlwa focus on the upward motion ke manje. V initial, choosing down as positive again. So the initial velocity is about minus 4,2 meters per second. Now basiphe yona la. Right? Basiphe yona. So the initial, I'm sure this is the It's when the ball bounces vertically upwards with a speed of, so the initial yoba negative ngoba we're choosing down as positive. So in a gravitational acceleration 9.8 meters per second squared, plus it's acting downward, siyabuya siba overfuna the maximum height. So this time is funa delta y. Sifuna delta y, and we know ukuthi nayo fika la ku b, the final velocity yoba equal to 0. As consulte ilo kanje ke manje the formula sheet. As consulted the formula sheet, so now my equations rate of motion. So sebenzisa which formula to calculate delta y? Yeah, this one. This time babedile la. Why bafaka bu a about 2? Why bangavelanga bakhupha from one of the question papers? Beka bayenzi error la. It's supposed to be delta y, not delta a, ne? All right. Okay. Now, all right, let me erase lana and do this. Let's calculate to get this one. So to v final squared is equal to v initial squared. Is it plus or a minus? It's a plus 2 acceleration delta y. Let us substitute final velocity 0 squared, initial velocity minus 4.2 squared plus 2 acceleration 9.8. for now delta y this time. This is why we chose this formula. It's because of his formula or delta y are the only unknown in the equation. So lana it's 0, negative 4.2 squared equal to kumele ingene ku bracket. Uyabona umehluko ke ukuthi na ungafaka I bracket i-answer yakhe ihlezi positive, ihlezi negative, but if ufaka I bracket then you are square ihlezi iphuma ya positive. So it's 17,640 plus, is it 19.4, let's check it, times 2, yeah, 19.6 delta y azisheke. So it's minus 17,640 19.6 delta y, then divide both sides by 19. So 17,640 divided by 19.6 equal to delta y is equal to minus 0.9 meters. Therefore your answer here too, it's 0.9 meters up. Ungakhohlwa negative it's up and then positive it's down, right? Displacement ihlezi nani in a direction, angisho ihlezi in a direction. Okay, 343, the last question, but this is sketch a velocity time graph for the motion of the, or from the moment that the ball passes A, so from la A all the way up to position bani B. Clearly indicate on your graph position A, the velocity of the ball as it hits the ground, the time it takes for the ball to reach the ground and leave the ground. Okay, it's a lot. The velocity at which the velocity at the maximum height of the ball, or the maximum, okay, the velocity at the maximum height of point B. All right, okay, asuselana so that we can prepare the sketch. All right. Okay, now so okay, 343. Okay, now I think prepare the axis. Maybe now I later now this is my axis, x and y, x and y axis. All right, so now y axis wamla, this is the x axis. 0. This is the velocity time graph. Yeah, velocity versus time graph. Right again. Let's use a different color again. Bheka ke. This is position A. Lana on the y-axis ngiba ne velocity la. In alright. Ngizama ukuyiletha la kancane. Velocity in meters per second. So the initial velocity ubani u 8,4. Samkhumbula nangu la basiphe yena. We also bathi sikhombise the velocity of the ball at A. Check ngicedile na ngikhombile u 8,4 nayi. The velocity of the ball as it hits the ground. Si calculate ile sathola ukuthi la ingubani ingu 12,98, right? So check naku ke, right? Naku ke. So bheka ke manje la. Since I'm choosing down as positive, I chose down as positive kulama problems, kulama questions esiwaphendulile. So ngizoqhubeka nale direction le, right? So nangu ball A. So this is ball A. Ball A une initial velocity of 8.4 going downward. What happens to the velocity of the ball at A? Increase. Why increase? It's due to the gravitational force until it hits Guppy, it hits the ground ngale velocity le. After how many seconds? After 0,4 seconds. Nayi bas calculate yona la. The speed got 12,98 is reached after 0,48 seconds. Also show the time taken for the ball to reach the ground. Check. And leave the ground. Bese ke bathi kithi the ball is in contact with the ground for 0,20 seconds. So 0,47 plus 0,20 is equal to 0,67. So after 0,67 seconds, the ball leaves the ground. I think palele phezulu lo. It leaves what? The ground. 6,7. So from la to la, it's the contact time, right? This is when it hits the ground. This is when it leaves the ground. Check. The velocity of the the velocity at the maximum height of point B. So at the maximum height of point B, we know that izoba ubani, izoba 0. But le ball alisa move alona la. Basiya ukuthi okay, it leaves the ground. So lana it's in contact with the ground, so it leaves ngale velocity le upwards with the speed. Ubani 4,2, which is negative, right? Ngoba up is negative, down is positive. So therefore boom. So izosuka ngale velocity le ka 4,2. Then as it goes up, what happens to the velocity? It decrease. So it decreases until it reaches ubani point B. Ngoba at point B, the velocity is equal to 0. At the maximum height, the velocity is what? It's 0. So this is our velocity time graph. Okay, now sketch ama velocity time graphs or ama position time graphs. It's when uma uzoyidraw, you draw it as if you are telling sort of like a story nyana kanje. So like njengala each part of the graph ngitry ukuyi-explain, uyabona, ngitry ukuyi-explain, but it makes sense this way rather than ukuzama ukukremisa wona yabona lamalo kanje lama graphs la. Yes, so this is our velocity time graph. And the last question, no, it's not the last question, short are the last two questions la. All right, I think erase so that we can answer the last two. Okay, now 3.5, the question pendul. The soft ball is now replaced by a hard ball. How would this affect the following? Right, only increases, decreases, or remain the same. 3.5.1. Tennis ball niyayazi ngisho. A hockey ball, yes, I assume good niyayazi. A cricket ball, a hard cricket ball, I hope niyayazi. So instead of talking about the kanje, okay, I think what contrast la. This is a tennis ball. Now we drop her ngithi zeyenzana ifike ku ground izopotoka nyana. So yoti poto ibe in contact with the ground, then it goes all the way up again. Angisho. Hard ball. Nayi hard ball na ifika la ku ground izoenzani izothi go. Anyeke ipotoke ke yo. Anyeke ipotoke but izothi go. Izothi nayishaya phansi ithi go uyizwe ukuthi ayabona kuyinto ngate isindayo ke manje la yabona, and uyayizwa ukuthi iqinile lento le. So na ipoto angeke ipotoke man, uthini manje nayoshayisa la izobounce yona iye phezulu, izobuyela phezulu ngoba the ground is counteracting the force applied by the ball. Babuza ke la ku 3.5.1, the contact time when the ball bounces off the ground, will it increase, decrease, or remain the same? What do you think? It will decrease. It should decrease. Cabanga man, cabanga lento le ayipotoki. Lokupotoka loku kuthatha isikhathi ngathini ku-allowa lelo guy le bhola, le tennis ball nale ground to stick together for a moment. Then le ingapotoki ifuna ukuhamba masinyana yona, so ifika ithi go ivele ihamba yabona. So the contact time iba less for a hard ball. Ku 3.5.2, the height of the ball after it strikes the ground, explain. Izoba less or no, but izo increase, I decrease, or remain the same. Okay, the height of the ball after it strikes the ground. All right, babe. Izo increase. It will increase. Why do I say that? Ngoba there's less contact time la. There's less contact time, so I lose the energy eningi, just like this tennis ball. So go isheshe move, I lose the energy eningi yakuphi yaphezulu. So singathi it increases. Why? There's less contact time. There's less contact time. So this is the last question for this question 3. I hope we enjoy it. I hope we told some value. Check out the description box for other recordings, as well as a link to another channel for our lessons. Check it out. So for now guys, asibonane on the next lesson. I hope we enjoy it. Don't forget to like, share, and subscribe. For now, asibonane next time.